So now we're going to solve the same system, except we're going to use matrices instead. And this is going to kind of streamline our process, and we're going to have kind of an algorithmic approach to solving systems, and the matrices are going to help a lot. Okay, so it's going to use a lot of the same things that we just did solving this system in the previous video. We're just going to think about it a different way. So we're going to take the coefficients of the left side of our system and put them in a matrix. I'm just going to write them down exactly the way they are. I'm going to use a 0 in the third equation because there's not an x1 term here. So I'm going to call that matrix A. We usually name matrices capital letters. And we start with A. If we have another matrix, we'll call it B and C and so forth. The right side of the equation, we're going to call that vector B. And I use this little arrow vector symbol to let you know this is a vector. And all a vector is just a matrix that only has one row or one column, right? So you might have seen vectors written like this. But we're going to just write them like they're matrices that just have one column or one row. In the book, in a lot of books, you'll see vectors bolded in the top. And I can't bold my pen, so I'm just going to try to use this vector symbol for a while, and later on I might just drop it because sometimes it'll just be obvious that we're dealing with a vector. Okay, so next thing we're going to do is form what's called the augmented matrix. And all the augmented matrix is your coefficient matrix stitched together with this vector that we call B. And I like to draw a line to show that these two have been stitched together into a single matrix. Okay, so this is called the augmented matrix. And that just means they're put together. So before, when we solved this system, we were eliminating variables, and we had to fix the coefficients so that the coefficients would cancel out. And we're just going to do the same thing here, except we're just only going to deal with the coefficients because that's the only thing that really matters here, right? We're kind of making this, we're just creating a system that will allow us to solve these without having to worry about the variables. But we're always going to keep track of the variables this way. We're just going to say, well, the first column are the coefficients of x1, the second column are the coefficients of x2, and the third column are the coefficients of x3, and the last column is this b vector. And we're just going to remember that. Okay, we don't really have to deal with it until later, but I'm going to go through the same steps that I went through solving this system last time. I want to eliminate this entry here, this 2. And eliminate means I want to make it a 0. And I'm going to use the first row. The first row represents this first equation, right? And you can think of this line as like the equal sign, right? The line separates the left side and the right side of those equations. So this row needs to be multiplied by -2, and added to the second row. And I'm going to always write down the operations that I'm doing. It's going to help us keep track of steps that we did. In case we make a mistake, we'll go back, be able to find out where the mistake was more easily if we write down the steps. So this is what I'm going to say. I want to change the 2 to a 0, so I want to change row 2. So I'm going to say replace row 2 with this new row. And what row do I want to replace it with? Well, I want to multiply the first row by -2, and I want to add it to the second row. And you could also write it this way. You could say R2 minus 2R1 if you wanted to say that. Take the second row, we're going to subtract 2 times the first row. And I think it's a good idea when you first start doing this is instead of off to the side writing down all these additions and all these operations, just make notes on your matrix. So here I'm multiplying this row by -2, so I'm just going to write down what that means. It means that's going to be a -2. That's going to be a +4. This is going to be a -2. This is going to be a +2. Right? So I'm not actually changing this row, but I'm going to use -2 times this row to change the second one. So when I go to my new matrix, I'm going to write down the rows that I'm not changing. So I'm only changing the second row, so I can go ahead and write down the rest. So the second row minus 2 times the first row is going to be my new second row. So here I've got 2 and -2, that's 0. 1 and 4 is 5. -3, -2 is -5. And then 8 and 2 is 10. You can see this is the same thing that happened last time, except we weren't just using the coefficients. So remember, we simplified this equation here, right? This is 5x2 minus 5x3 equals 10. So I'm going to simplify this by dividing both sides of this equation by 5. And in terms of the matrix and the rows, that means I'm going to change row 2. I'm going to replace it with, I'm going to say 1/5 row 2. So we only really show multiplications when we do these row operations. So instead of dividing by 5, I'm going to multiply by 1/5. That's the same thing. So again, I'm going to write down the rows that I'm not changing. I'm not changing the first row or the third row. I'm only changing the second, and the second row is going to be 1/5 row 2. So I just divide that row by 5. So now, again, I want to eliminate this 5. And I'm going to use a second row. So that means I'm changing row 3. And I'm going to replace it with row 3 minus 5 times row 2. So if I multiply row 2 by -5, and add it to row 3, that 5 is going to become a 0, which is what I want. Right? I'm still eliminating the variables, right? And I'm just going to make notes here of what's happening. I'm going to multiply this by -5, so it's going to be -5 plus 5 and -10. And I'm going to write down the first and second rows. And I'm only changing the third. So 5 minus 5 is 0. 2 plus 5 is, 0 plus 0 is 0, and then 5 plus -5 is 0. I forgot, I did that in the wrong order. 2 plus 5 is 7, and -10 and 3 is -7. So if you remember what we did last time, we divided both sides by 7 here. So I'm going to replace row 3 with 1/7 row 3. I think starting out, you should write down every single step until you get the hang of this. on a test, your teacher might ask you to write these steps down, so it'll be easier for them to grade. So you want to write them down to start with, and do every step individually. You can do multiple steps at once. Starting out, you probably just want to do one at a time till you get the hang of it. So this is that triangular form that we got last time as well, right? And we could back substitute here. We could stop our row reductions and just go back to the system and back substitute. But what's nice about matrices is you can really see everything, and we can take this further. I'm going to keep on eliminating variables, okay? So my next target is this -2. I'm going to use this 1 to do that. So I'm going to multiply row 2 by 2 and add it to row 1. So I'm going to change row 1 with row 1 plus 2 row 2, right? So if I multiply row 2 by 2, right, I'll get 0 here, 2, -2, and 4. And I'm going to write down all the rows I'm not changing. That's the same process here. I'm going to add these two rows, the row in the red here, the one I've multiplied by 2. So 1 plus 0 is 1. -2 plus 2 is 0. 1 plus -2 is -1. And -1 plus 4 is +3. And I'm going to keep going. Let's eliminate this entry, and I'm going to use this row to do that. And here I could just straight add them together, right? So I'm going to replace row 2 with row 2 plus row 3. That's already going to cancel. So row 1 stays the same. Row 3 stays the same. And I'm going to get a new row 2 by adding row 2 and row 3. So that will be 0, 1, -1 and 1 is 0, and 2 plus -1 is 1. And you can see I've got 1 left to go. Going to take out that -1 in the first row. And I'm going to use this 1 here to get rid of that -1. So again, I'm going to add these together. So I'm going to replace row 1 with row 1 plus row 3. So row 2 stays the same. Row 3 stays the same. And row 1 is going to change. I'm adding row 3. So 1 plus 0 is 1. 0 plus 0 is 0. -1 plus 1 is 0. And 3 plus -1 is 2. Okay. So once I've got to this point, I'm done. And remember that these columns were coefficients of these variables. This line is an equal sign, and this is a vector of constants on the right side of the equal signs. So if I read these rows out, the first row says x1, 1 times x1 plus 0 times x2 plus 0 times x3 equals 2. So this tells me that x1 is equal to 2. So it's already solved. And the second row says 0x1 plus 1 times x2 So the second row says 0 times x1 plus 1 times x2 plus 0 times x3 equals 1. So that tells me x2 is equal to 1. In the third equation, you can see 0, 0, 1 times x3 is equal to -1, and that is the same solution that we got using back substitution. So this method of solving systems this way has got two different names that people use. One is Gaussian Elimination, and the second name that's popular is gauss-jordan elimination, or reduction. Sometimes it's called reduction. So Carl Friedrich Gauss started doing this, figured it out. I think Jordan used it a lot and made it popular. Okay, so he used Gauss's work and made this kind of a standard method. Now let's go through the method, because I kind of walked you through steps, but I didn't really explain the overall picture. What do you need to do to make this work? So the first step is, I'll use purple here. The first step is to make this top corner a 1 if you can. Sometimes you can't, but here we're going to make it a 1. And it already was a 1, so we didn't have to do anything there. The next step is to use that 1 to make every other member of that column a 0. Now I already had a 0 in the third entry of the first column, so all I had to do was get rid of this 2. That's what I did here. So that means our first column was done after just one step. Okay, but it could take you more steps on a different problem. The second thing you want to do is move down and to the right to this in this case it's the middle entry. We want to make that a 1. So I divided by 5 and I got my 1 here. And then you want to use that 1 using elimination, right? Using the same things that we did when we took our algebra class and used elimination method. We want to use elimination to make the other entries of that column equal to 0. Now, I first made the 5 a 0, and then I went ahead and made this entry a 1, but then I came back and made the entry up top a 0. So at this point, that second column is done. And then again, you want to move down and to the right, and you want to make this entry a 1. And it was a 7 before, and I just went ahead and made it a 1 because that's kind of what we did before. But you know, the algorithm is to wait until these entries are 0. But I went ahead and did it. So when that's a 1, then you make these entries 0. And it took 2 steps, and we got that column to look like this, 0, 0, 1. And if you can get it to look like this, then you get one solution, and that is a unique solution. This is a one solution where all these things are intersecting at a single point. And that is Gaussian elimination or Gauss-Jordan elimination. Now, sometimes you can't get it into this form, okay? And we'll talk about what it'll look like if you can't get it to this form. And you might have different size matrices. You know, you might have 4 equations and only 2 variables, or you might have 6 variables and only 3 equations, right? So these things can have different shapes, but we're going to generally use the same process. We're going to create a 1, make everything else 0 in that column. We're going to find another place to make a 1 and then make zeros in the columns. And we'll just keep going until we run out of things to do.